Good morning, 8th grade. We are going to go ahead and get started on the second half of Chapter 6, and we're going to start with Section 5. And we're going to talk today about something called linear inequalities. So let's go ahead and, before we get started, do some vocab. Just one today, and it is linear inequality. All right, remember your inequalities. You have symbols like greater than, less than, greater than or equal to, less than or equal to, and so forth. Okay? So linear inequalities are oops, I meant to put a colon there. Sorry. That's better. Linear inequalities are similar to linear equations like we've been dealing with. And they are graphed the same way. Okay? There are a couple slight differences which we will talk about, when we get to that, but you graph them pretty much the same way you would a regular equation. The only difference is you're going to have a lot more solutions to linear inequalities than you would to a linear equation. The only constraint you have is that the solution must satisfy or make true the inequality. As long as it makes it true, then it's a solution. Okay? So before we actually get into graphing them, let's take a look at some solutions, and we're going to see if they make the inequality true. And again, if I'm moving too fast for you guys, you can pause, rewind, do what you need to do. Okay, so let's start here. This is number 1. Is the ordered pair a solution? Okay, so here's what a linear inequality is going to look like. Instead of y equals x minus 3, it's going to be y greater than x minus 3. Okay? When we go to graph it, you can pretend that that's an equal sign and go ahead and graph as you normally would. The only difference here is the sign that's in the middle. And we're going to check to see if 1, 2 is a solution to this inequality. So we're going to plug it in just like we would if it were a linear equation. This guy goes in for x, this guy goes in for y, and we see if it's true. So instead of y is greater than x minus 3, is 2 greater than 1 minus 3. And we see that 2 is greater than negative 2. Is that true? Yes, it is. So this is a solution for that inequality. Okay, let's try another one. Let's say we had y is greater than or equal to 2/3 x plus 4. And I want to check to see if 3/6 is a solution to that inequality. What I'm going to do, plug in 3 for x, plug in 6 for y, and see if it satisfies the inequality. So is 6 greater than or equal to 2/3 times 3 plus 4? 6 greater than or equal to 2/3 times 3 is 2 plus 4. And 6 greater than or equal to 6. Yep, that's true. So this is a solution. The only case it would not be a solution is if, it wasn't true. If I got something like, 6 greater than or equal to 12, that's not true. So then that wouldn't be a solution to the inequality. Okay, we're going to actually get into graphing these now. So if you have some graph paper, that you want to use, go ahead and grab a sheet. If you don't, no big deal. Alright, so I'm going to start it down here, but then I'm going to hop on over to my sheet of graph paper. 2. How to graph a linear inequality. Alright. So I'm just going to put underneath C graph paper, because that's where I'm going to be working. If you are not working on a sheet of graph paper, just, continue on your notebook paper. But I'm going to use graph paper. Alright. There we go. And I'm just going to, I already marked it as 6-5, because that's the section we're on. And this is 2A. And I'm just going to circle it. Okay. So the inequality we're going to deal with first is, we'll do a simple one. Y greater than x minus 2. Okay. Now there are some differences when we're talking about inequalities, but we're just going to graph it first like it's a regular, normal linear equation. Pretend that that is an equal sign. Y equals x minus 2. And we'll graph from there. So if this was y equals x minus 2, I draw, look how straight that line is. Oh my gosh, that's beautiful. And draw, oh, that one too. I'm on fire today. All right. So we graph this like a regular linear equation. I look at my y-intercept. It's -2, so that's where I'm going to start. And my slope, there's no coefficient in front of x, but we treat it like it's 1, because 1 is in front of x. It means I have a slope of 1. So we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so forth. All right, don't draw a line yet, just wait. If your linear inequality has greater than, like this one does, or less than, you're going to use a dashed line. Okay? Greater than or less than gets a dashed line. So when I go ahead and do this, I'm going to go straight through with a dashed line. Let's see if I can get that through there. There we go. I still put the arrows because it does continue on in either direction. Now there's one more thing that we have to do. Remember how I said in the beginning that there are going to be a lot more solutions for linear inequalities? You want to look at which way your sign is pointing. Okay, it is greater than. You know what? Just to show you how this would work, I'm going to pick 2 random points. I'm going to pick a point. Actually, I'm going to pick 3 points. Yeah, I'm going to pick 3 points. I'm going to pick a point that it's above the line. I'm going to pick a point that's on the line. And I'm going to pick a point that is below the line. And I'm going to show you why I'm doing that in just a moment. So I'm going to pick this one. That's -2, 1. I'm going to pick this one right here. This is one on the line. That is 1, -1. And I'll pick this point. That is 1, -1, 2, 3, 4. 1, -4. Okay, you do not have to do this every time. The only reason I'm doing it now is to kind of illustrate the next step that we would take for the linear inequality. You do not have to do this every single time. And I'm just going to plug them in, each of them over here. So I'm going to plug in -2, 1. I'm going to plug in 1, -1. And I'm going to plug in 1, -4. Each time into the inequality that we graphed. Okay? So I'm going to pause, plug in, and I'm going to show you what we're going to do next. Okay, so I have plugged in those 3 points. Okay? This is the point above the line. This is the point that was on the line, and this is one that was below the line. You can see that the only solution that worked was the one that was above the line. All right, it was the only one that made it true. So here's another thing that you're going to see. If you have a symbol that says greater than, you are going to shade in all of the points that are above the line. Any point up here will make that inequality true. Okay? Let me go this way too, so it's a little darker. There we go. Okay? So that's why with inequalities, you're going to have many, many more solutions than if it was a linear equation. Linear equation, it's just what is along the line. If you have a linear inequality, it's going to be, it depends on if it's greater than or less than, because if it's greater than, you shade above the line. If it is less than, you shade below the line. Let's write that somewhere. I'm going to put it over here. If you have greater than or equal to, both will work. You shade above. Okay, if you have less than or equal to, you shade below. Okay, now you do not have to plug in each time you do your inequality. But let's say you're, not sure. When we get to vertical lines, it might be hard to tell, well, is this above or is that above? And what you can do, just pick a point, plug it in. If it's true, you know where to shade. Let's try another one. I'm going to head down here, and I'm going to write 2b. Or not 2b. That is the question. Okay. Here we go. So again, I'm going to write for us an inequality. Let's do y is less than or equal to 1/2 x plus 1. Okay? And I'm going to draw, oh, this one's not as straight. That's okay. They can't all be straight. And like that. Good enough. Okay. There's my x and y axis. So, I'm going to graph this as if it were a regular equation. Pretend it's y equals 1/2 x plus 1. And then you can graph it. So here is my y-intercept. So I'm going to plot my first point there. The slope is the coefficient in front of x, which happens to be 1/2. So I'm going to go up 1 over 2. Up 1 over 2, up 1 over 2, and I'll plot some beneath as well. There we go. Okay. Oh, I smudged. Oh, well. Okay. Now, this one is slightly different because you'll notice it's less than or equal to. Okay? So when I do this one, if you have less than or equal to or greater than or equal to, you're going to have a solid line going through the points. And I'll show you why. So I'm going to draw a line, solid line going through. Okay? And once again, I'm going to plug in 3 separate points. You don't have to do that every time. It's just to illustrate to you, why it's this way. Okay? So I'm going to pick 3 points. I will pick a point above, a point on, and a point below. So let's do, I'll pick this one. That is -2, 2. Okay, I'm going to pick a point on the line. That's 2, 2. And I will pick a point below. I'm going to do all 2's. Why not? That is 2, -2. Okay, so what I'm going to do, and again, you don't have to do this every time. It's just to show you why this happens. I'm going to plug in these 3 points. and show you how this works, okay? So this is the one that's above, this is on, and this is below the line. Okay, and I'm going to plug them in to my inequality that I graphed. Okay, so I'm going to pause, plug in, and then I'll show you which of these are going to be solutions and which will not. Alrighty, that's a little messy, I apologize for that, but you can see that for this one, anything that was above the line did not work. I plugged in this point, it did not make it true. I plugged in something that was on the line, and it was true, because we have that equal to bar. I plugged in something that was below the line, and it was also true. So, if you have something that says less than, you're going to shade below the line. Anything I plug in down here will make that inequality true. Any point that is below the line. But since we have that equal to bar, anything on the line will also be true. So in our first one, we did not have that equal to bar. We just had greater than. So if you have greater than or less than, anything on the line will not work. If you have less than or equal to, anything on the line will work. Okay, because you have that equal to bar. So that is how you graph them. All right, you graph them like normal. You see which sign you're dealing with. Okay, if you have greater than or less than, it is a dashed line. Okay, the reason it's a dashed line is because nothing on there is going to work. The reason these guys get a solid line is because right along this line, those will still work. They will, by work I mean when you plug them in, they will satisfy the inequality. They will make it true. Okay, then you also need to see which direction am I dealing with. If it is greater than, you shade above, greater than or equal to. If it is less than or equal to, you shade below. Okay? Let's try, we're going to do two more. These ones might be a little bit weird, only because it might be hard to see. I'm just going to go on the back here. Kind of hard to see my lines, but that's okay. Only because they're odd lines to begin with. Okay? So I'm going to write this as 3a. Okay? And I'm going to draw y-axis and x-axis. Alrighty. And I'm going to graph x greater than -1. So I'm just going to pretend for a hot sec that this is x equals -1. We know that whenever it's x equals something, it's going to be a vertical line. So I'm going to, since it's greater than, this gets a dashed line. So I'm going to draw a dashed line through -1. And it would look like that. Oh, I smudged again. Sorry, guys. So, where do we shade? X is greater than -1. Think for a second, which side of the line here for x is going to be greater than -1? Everything here is negative. So, for example, if I picked this point, that's -4. -4 is not greater than -1. Since it's a dashed line, nothing on there is going to be a solution. So it's got to be everything up here. If I plugged in this would be 1. Is 1 greater than -1? Yeah. So I'm going to shade above. This is above for this particular line. So everything up here would be a solution. Okay? Let's try another one. This will be 3b. This time we're going to do something with y equals, but there's going to be no x value. So y is less than or equal to 2. Okay, pretend for a second that it's, stop moving. Sorry guys, my paper keeps sliding. Stop it. Pretend for a second it's y equals 2. We know that if we have y equals something and there's no x related to it, that it will be a horizontal line. Ooh, sorry, that is not a straight line there. Okay? So we're going to draw this. In this case, it's going to be a solid line because it's less than or equal to. So I'm going to plot a point at y is 2. Draw a solid line through that point. And there is my graph. Bleeding through a little bit on this side. Sorry about that, guys. So, where am I going to shade? It is less than. Think about it. If I had my line, if I picked this, -1, 2. Okay, so -2, is that less than or equal to 2? Yeah. So I'm going to shade everything below that line. Okay, so that's how you graph those two particular lines. We are going to pause here because this video is getting a little bit long. We will finish this section probably tomorrow, where we take a look at some word problems that go along with linear inequality. So that'll be it for today, guys.